Hi, thanks for joining me today. I'm going to be going over problem 1H from Math 2023. We want to know which of these triangles has the largest area. So these are all about isosceles triangles where two of the side lengths are 10 and the remaining side length is either 1, 5, 10, 15 or 19. And we want to know, which of these has the largest area. Okay, so if you want to have a go at this problem, pause the video now and give it a go for yourself. And I'm going to dive straight into a solution. So there's actually a couple of ways we can approach this, but I think the most intuitive way is at least to start by drawing a little picture here. So if we call, that side length will be 10, and that side length will also be the other 10 here. Oh, hasn't been drawn, great. And then we'll call this remaining side length here x. And so x is either 1, 5, 10, 15, or 19. Can I work out the area of this, what's supposed to be an isosceles triangle, in terms of x? And then I can perhaps just plug in the numbers 1 through 19 here. We can just do that. So if I start by drawing this dotted line here, I know this base here is going to be x over 2 for this, and then I can use Pythagoras' theorem here to work out the height. So the height is just going to be the square root of 100 minus x squared over 4. So that squared minus that squared, and then square rooted. Okay, so that's the height of our triangle. And so therefore, what's the area? Well, it's just a half base times height, so it's a half. The base of this triangle is x, and then the height of this triangle is going to be root 100 minus x squared over 4. Okay, and now I guess what we can do is just plug in each of these 5 numbers here. So we'll start with just I'll use a subscript 1 to denote when x is 1. So a half times 1 times, root of 100 minus a quarter. Well, this is going to be, maybe I'll do this by approximation. So this is a half times 1 times root 100, which is approximately a half of 10, which is 5. Okay, cool. So that's A1. What about not A2, let's go A5 next. So if I plug in x is 5, so we get a half times 5 times root of 5 squared over 4, so that's going to be 25 over 4. 25 over 4 is about 6, so we've got a square root of 100 minus 6, so again it's roughly 10 here. So I'm just going to keep in the back of my mind these are rough approximations, so as long as these are all relatively far apart, I won't have to do too much more further investigation. So half 5 times 10 is 25. And yeah, this is considerably bigger than 5, so I'm pretty confident that A5 is bigger than A1. Okay, how about A10? Well, this is going to be square root, half times 10, so 5 times the square root of 100 minus 100 over 4, so square root 75, and that's roughly 9, slightly less than 9, but yes, that's going to be approximately 45 here. Okay, what if I plug in 15 here? So then A of 15 is going to be half times 15, so 7.5, or right, it's 15 over 2, times the square root of 100 minus 15 squared over 4. Well, 15 squared is 225, which is, roughly 224, and if I divide that by 4, I get 56. So 100 minus 56 is roughly 44, and so square root of 44 is roughly 7. So this is going to be 75 over 2 times roughly 7, and so that's 7.5 times 7, which is, bigger than 50. Okay, so that's pretty good. How about A19? Well, A19 is going to be a half times 19 times the square root of 100 minus, 19 squared over 4. Well, 19 squared is 361. If I divide that by 4, that's roughly 90. 100 minus 90 is roughly root 10, and that's about 3-ish. So this is roughly half times 19 times root 9, which is roughly 3. Root 10, which is roughly 3. And so this is going to be, 57 over 2-ish, but that's definitely less than 30. So it looks as if this guy here is the biggest. So A15, so the answer is going to be D here. So when that remaining side length has side length 15 here, the area is going to be maximized. And that's basically because this number is considerably bigger. Even though I have had to approximate these, using the approximation actually isn't too bad, because 50, or something that's bigger than 50 is definitely going to be significantly bigger than 45. And in fact, I think this thing here was less than 45 because it was 5 times less than 81, root 81. So yeah, this is less than 45. This is bigger than 50. The answer is 15 here, so option D. Yeah, so this is essentially how you solve this problem. Kind of another way to think about this is thinking about, well, all of these triangles have side length, two of the side lengths as 10. So if we call this angle theta here, we know that the area of this triangle is going to be a half times 10 times 10 times sine of theta. And so that bit there is 50, but it's in particular it's a constant. So it's 50 sine theta. So if we're trying to make this as big as possible, we want sine of theta to be as big as possible. And that means that we need theta to be as close to 90 degrees as possible. And you can think about this, but it's not too difficult to convince yourself that the final side length being 15 would be the one that corresponds to theta being as close to 90 as possible with these 5 options here. Anyway, I hope this solution has made sense, and I hope you find this video interesting. Thank you for watching. I'll catch you in the next one. Have a great day.